Hello, everyone, and welcome to this episode. Today, we are doing some multiple choice questions in relation to AP Chemistry, Unit 7, Chemical Equilibrium. Specifically, we're looking at LeChatelier's principle and the multiple choice questions that might go along with which direction is the equilibrium going to shift. I should note that I do have a full length video on just LeChatelier's principle, the concepts, and everything. You'll find it in the AP Chem Unit 7 playlist. So if you haven't already watched that, maybe go check that out first and then come back here for the questions. So let's get started. Let's start with this first one, which involves a gaseous equilibrium between nitrogen monoxide and carbon dioxide and these two products. The question is asking which of the following changes will increase the amount of NO2 in the equilibrium system represented by the equation above. So we're increasing NO2, which means we have to move it to the right to create more products. So what are the things that we could do to do that? One of the things we could do is add or remove selected parts of the equilibrium. So adding a reactant, for example, will shift it to the right. Removing a product will shift it to the right. So if I'm going to go to the right, then I'm looking for one of those two, and we have removing CO from the system. That is actually removing a product, so that would make it shift to the right. I'm just going to double check the other ones. Removing CO2 on this side would actually make it shift back to the left. And increasing or decreasing the volume of the container. They sound like good answers, and they might have you thinking about it, but there's no benefit to the equilibrium either way because there are the same number of moles of gas on either side of the equilibrium. So increasing and decreasing the volume only changes it when there's a difference in the number of moles on either side. So let's circle A. That is our final answer. Okay, let's look at another one. Consider the equilibrium above. Which of the following changes will increase the concentration of HgI4 2-, which is that one. So again, we're trying to increase the thing on the right and make it go to the right. This one's a little bit trickier because we have to kind of think outside the box here a little bit. So increasing the concentration of OH, that would actually shift it back to the left. Increasing the mass of HGO present. Okay. This is tricky because it kind of makes you think that adding more of this will make it shift to the right. And it would if this were not a solid. Because it's a solid, it doesn't belong in the equilibrium constant expression, and its concentration doesn't really matter. So it's kind of a distractor answer, so don't pick that one. Increasing the temperature, maybe, but I don't know if this thing is endothermic or exothermic, so I can't use that as my answer. Adding 6 molar HNO3 will affect the equilibrium, though, because this is an acid and this is a base. So by adding the acid protons, we're actually going to make it react with the OH hydroxide ion, and it's going to form some water, which effectively decreases the amount of OH that we have, and so it will shift to the right to make some more of that. So adding 6 molar HNO3 is our answer. Okay. Another kind of trickier one, we have a dichromate equilibrium up here, dichromate and chromate, orange and yellow. And we're asked, again, pause the video if you ever want to just read it a little more carefully. I'm kind of running through these pretty quick. Which of the following statements correctly predicts the result of adding a sample of 6 molar NaOH to the system and provides an explanation? Okay, so we're adding sodium hydroxide, right, which is a base. And do I see anything up here that is an acid? Yes, I see this over here, which is an acid. So because the base will react with the acid, let's write the equation just because we can. We're going to get neutralization of that hydronium ion into two waters. It'll drop it out of solution. The thing will go to the right, and it will become more yellow because it will shift the equilibrium toward the products. So you kind of have to keep your eyes open for acid-base reactions in equilibrium. All right, next one. Which of the following changes will increase the amount of NO2 in the reaction system at equilibrium? So again, which of the following? And we're looking at adding a catalyst, increasing the pressure, increasing the temperature, or decreasing the volume. Okay, first things first. We have to have some laser focus here. Doesn't letter A sound great? Doesn't letter A just sound really official and wonderful, and you just want to pick it because catalyst is a really cool word? And you might think, well, adding a catalyst, make it go, right? No, it'll actually do nothing to affect the equilibrium and the equilibrium constant. It might affect how fast it gets to equilibrium, but it will not affect the equilibrium constant. And so keep your eyes peeled. They'll put it in there. Don't pick it. It's a distractor. You'll be tempted to pick it, but don't. Increasing the pressure. So if I increase the pressure by adding neon, okay, here's another one. Okay, again, laser focus. Doesn't that sound good? We're going to add some neon and increase the pressure. And you're probably going to be asked that question, but don't pick it because adding a noble gas or an inert gas doesn't do anything to the equilibrium. It sounds cool, but it doesn't do anything. It doesn't change the partial pressures of these three guys in equilibrium with each other, so the equilibrium is not going to change. Increasing the temperature at constant volume. By increasing, this is an exothermic reaction, so heat is produced. Increasing the temperature is kind of like adding a product. It's going to shift back to the left and decrease the NO2. The only other option we have is decreasing the volume at constant temperature. This is a way that we can actually increase the pressure. We decrease the volume, the molecules start to say, oh, wow, it's getting cramped in here. Let's shift to the right to make less molecules and ease the pressure a little bit. So we're going to go with letter D. We have a reaction of lithium nitride and some hydrogen to make this guy and this guy over on the right-hand side. We can see from the negative delta H that it is exothermic. And it says because pure H2 is a hazardous substance, it is explosive. Safer and more cost-effective techniques to store it as a solid for shipping have been developed. One such method is the reaction represented above. The amount of H2 present in the reaction at equilibrium can be maximized. Let's say we want to get the hydrogen back by doing one of these four choices: increasing or decreasing the temperature, increasing or decreasing the pressure. So we got all four combinations there, which is pretty common in a multiple choice question. Okay, so let's talk about temperature first. It's exothermic, heat is produced. If I want to make it go to the left, I want to give it some heat, which is like a product, and make it go back to the left. So I want to increase the temperature. That means I'm choosing A and B. I've already narrowed my choices. Then I also want to talk about pressure here for a moment. Will it help to increase or decrease the pressure? Yes, it will, because these are all solids, but that's a gas, and that's the only gas that's present. And so if I want to produce more of that gas, let's decrease the pressure by making the volume bigger, and the reaction will shift to fill that new space with more hydrogen, and we will get more hydrogen gas out of it. Okay, your turn. Let's try a pause the video moment. Here's a reaction, and we've got which of the following explains the effect on the equilibrium constant, Kc, when the temperature of the reaction is increased to 650 K. So take a moment, pause the video, and see if you can guess this one correctly. And if you guessed C, the Kc will decrease because the reaction is exothermic. Adding heat will make it go to the left and decrease the K value. Okay, great. Let's do another pause the video moment just for fun. Here's another reaction. Delta H for this one is positive. Which of the following changes will increase the number of moles of HOCl, which is the product present in the system? Take a moment and pause the video and see if you can get this one. All right, and if you avoided choosing letter C, congratulations, you have been paying attention. Do not choose adding a catalyst. Nope, won't do anything. There it is again. They're trying to trick us all the time. The way to do this is increase the temperature, because heat is now a reactant and heat is consumed. So by increasing the temperature, it will go back to go to the right. All right. You'll see a lot of similarities between a lot of these questions. The reaction system represented above is at equilibrium. Which of the following will decrease the amount of calcium oxide in the system? Okay, so decrease the amount of the product. So we want to make it go back to the left. Okay, and which of those choices is good? So increase in the volume. Well, first thing you got to notice, and this is a public service announcement, whenever you see an equilibrium system equation, check for solids and liquids because they don't count. They're part of it, but they don't change the equilibrium constant at all because they have constant concentrations. So I only have a solid, and a gas. That's the only thing that's really to worry about here. Increasing the volume will actually make it want to produce more gas, so it's going to go to the right. That's not my choice. Lowering the temperature of the system. That's positive, which means heat is a reactant. Lowering the temperature is going to make it want to go to the left and produce more heat, and so calcium oxide will decrease. Removing some CO2 will make it go to the right. Removing some of this will not change anything because it's a solid, and just removing some of the solid is not going to change anything. So lowering the temperature is my answer. All right, final pause the video moment for this episode is a three-parter. We have N2O4 and NO2. Kp is 3 at 70 degrees Celsius, and we have three questions. Which of the following best predicts how the partial pressure of the reacting species will be affected if a small amount of argon, attention, is added to the equilibrium system? Which of the following statements best helps to explain why the contents of the tube containing the equilibrium mixture turned a lighter color, colorless, when it was placed in an ice bath? And if N2O4 is 1.33 atmospheres when the system is at equilibrium at 70, what is the pressure of NO2? Take a moment, try all three if you'd like, and we'll be back here in a couple seconds to check the answers. Okay, and again, if you correctly avoided the being tempted by the argon is an inert gas, no change will take place in that reaction. The forward reaction is endothermic because if we imagine that heat is over here and we cool it down, it's going to want to shift toward the colorless side and so get a little bit less. And if you did the math, plugging in 3.0 is the K value, 1.33 atmospheres for the N2O4, you would get a value of 2 atmospheres for the NO2 by plugging into the equilibrium expression. Well, there you have it. A bunch of questions about LeChatelier's principle in multiple choice form, very typical of the type you're going to pretty much 100% see on an AP chemistry exam or even your own chemistry exam in class. I hope you found it helpful. If you have questions, send them to me in the comments or directly. And in the meantime, happy studying and have a great day.